Question 3, and here we have f of theta equals 4 cos squared theta minus 3 sin squared theta, and part A we're trying to show that that is equivalent to a half plus 7 over 2 cos 2 theta. So for this we need to remember our double angle formulas for cos 2 theta. So cos 2 theta, if you remember, is first of all cos squared theta minus sin squared theta, and we can generate that from the formula booklet here. So remember, if you replace the b with an a and you get a plus a, then you got 2a, so then that's cos a, which is cos squared a, minus, taking the top root, sin a, so that's sin squared a. So cos squared a minus sin squared a, or in this case cos squared theta minus sin squared theta. Now cos squared theta can be replaced with 1 minus sin squared theta from the year 1 identities. Okay, and tidy that up a little bit. We've got 1 minus sin squared theta minus another sin squared theta, so that's 1 minus 2 sin squared theta. Going back to here again, we've got cos squared theta minus sin squared theta. We can replace sin squared theta with 1 minus cos squared theta, again from the year 1 identity there. Now push that minus through, you get minus 1 plus cos squared theta, so you get a positive cos squared theta added to this one. That's 2 cos squared theta, take away 1. Okay, so these two formulations here of cos 2 theta are going to be very useful here to help us replace these two functions respectively with cos 2 theta. Okay, so if I call that version 1 and I call that version 2. In version 1 then we're going to try and make sin squared theta the subject. So first of all I've got cos 2 theta equals 1 minus 2 sin squared theta. We're going to add the 2 sin squared theta across to make it positive, and then take the cos 2 theta to the other side, and then that becomes negative like that. Finally then, to make sin squared theta the subject, divide through by the 2 and you get half minus a half cos 2 theta. Same idea for using version 2. This time we've got cos 2 theta equals 2 cos squared theta minus 1. The cos squared theta here is positive, so we'll leave it as positive. So then we'll move the 1 to the other side. Okay, so adding it across is going to give cos 2 theta plus 1 there. And then again, similarly, divide by 2 to make cos squared theta the subject. Okay, so sin squared theta equals a half minus a half cos 2 theta. Cos squared theta equals a half cos 2 theta plus a half. Now in each case then we're going to substitute that in, so therefore f of theta is now 4 lots of cos squared theta, but cos squared theta can be replaced with a half cos 2 theta plus a half, minus 3 sin squared theta, where sin squared theta can be replaced with a half minus a half cos 2 theta, like so. Okay, and when pretty much there, we just need to expand and tidy up a little bit. So 4 times a half is 2. 4 times a half is 2 again. Minus 3 times a half is minus 3 over 2. Now minus 3 times minus a half plus 3 over 2 cos 2 theta. Tidying that up, 2 cos 2 theta plus 3 over 2 cos 2 theta, that's 7 over 2 cos 2 theta. Positive 2 minus 3 over 2 is plus a half. Okay, and then just checking the format we're aiming for, a half plus 7 over 2 cos 2 theta. Well, that's basically what we've got. Just to be pedantic about it, I'll flip the order. And there we go, QED. Okay, in part B then, we asked to integrate f of theta with respect to theta between 0 and pi over 2. It's a hence in the question, so it's hence using calculus, find the exact value of that. So that means use the answer to part A. Hence for f of theta here, I've substituted in immediately the what we finished with in part A, which is a half plus 7 over 2 cos 2 theta. Okay, that's because this is now reasonably easy to integrate. So integrate a half, with respect to theta, we're going to get half theta. Integrate 7 over 2 cos 2 theta with respect to theta. Now, if we remember, we've got this diagram here, where going clockwise is differentiating, and going anti-clockwise is integrating. And here we're trying to integrate cos, so we're going to, when you integrate cos, you go back to sine. Okay, so integrate cos, you get back to sine. However, the inside function there is 2 theta, so we apply the inverse chain rule and we divide by that 2. Okay, and I'm just going to put that in there as a multiplication by half is the same as dividing by 2. So I'm going to put that, represent that there. Okay, just tidying this up a minute. A half theta plus 7 over 4 sine 2 theta between 0 and pi over 2. Okay, we're now ready then to sub our limits in. So first of all then we've got a half times pi over 2 plus 7 over 4 sine of 2 lots of pi over 2. And then we've got a half times 0, well that's just 0, plus 7 over 4 sine of 2 times 0, which is 0. Okay, now 0 obviously doesn't affect anything. Sine of 0, if you remember from the graph or just check it on your calculator, sine of 0 is also 0 as it happens. It isn't always the case. Cos 0 is 1, but sine of 0 is 0, so that is going to effectively not have any impact. Now this is also interesting here. We've got sine of 2 times pi over 2, which is sine pi. Okay, and sine pi is also 0. Check that on your calculator if you like, but sine pi is also 0, so that's going to disappear too, leaving us simply then with pi over 4 from that first term. Okay, and that's our final answer.